Hey everybody, it's Mr. Bedard. We're going to start a new unit on trigonometric ratios, but before we begin, if I could just have you take your calculator out, we'll use the wabbit on that calculator, and just do me a favor please and press the mode button, and just go ahead and make sure your black box is on degrees. So you're going to go down, put the cursor on top of degrees and hit enter, and make sure that your calculator is set to degrees. It will matter, and you can tell if you're correct by pressing something like, if you press like the sign of 30 and hit enter, it should say 0.5. So again, sign, okay, right above the comma, and then 30. If you're reading 0.5, then you're in good shape. Okay, so with trigonometric ratios, there's three of these. They're called sine, cosine, and tangent. They're all abbreviated by the first three letters of their name. So you'll see here on the right, SIN is sine, COS is cosine, TAN is tangent. And they're defined. So they're defined as finding the sine, cosine, and tangent of a specific angle. In this case, we're referring to angle A. Okay, so angle A is our angle of reference. So the sine is always defined as the opposite side over hypotenuse. So from A, go to the picture now, which side is opposite angle A? Well, that would be side CB. I'll put op. And the hypotenuse is opposite the right angle. So that's going to be side AC. So that will be defined as basically CB over AC in this scenario. Now the cosine is defined as the adjacent side over the hypotenuse. So what's adjacent to angle A? Adjacent is next to, isn't it? So adjacent should be side AB. All right, so the adjacent side over the hypotenuse, that would be AB over AC. And tangent is defined as the opposite side over the adjacent side. So in this case, it's already labeled. The opposite side is CB, and the adjacent side is AB. So these trigonometric ratios are always written like this. We use a mnemonic to help us remember, and that mnemonic is called SOHCAHTOA. Okay, and what it really stands for, and I'll just kind of write it a little bit differently. Sometimes you'll see people write it like this. The SO, or the S stands for sine, the O stands for opposite, over the H is hypotenuse. For ka, sometimes people will write it like this. The C stands for cosine, and that's adjacent over hypotenuse. And tangent is opposite over adjacent. What will happen, and you'll see this in a few examples as we go, is some of these are going to slightly change. So in example 1, it's just saying find the trigonometric ratios for what we have. So let's look at parts A, B, and C. Now for parts A, B, and C, we're all referring to angle A. So I'm going to label what is opposite, what is adjacent, what is hypotenuse. Now, a piece of advice I would give you is label the hypotenuse first, because the hypotenuse is never going to change. That's always opposite the 90-degree angle. Now, from the perspective of A, because again, notice in part A, B, and C here, we're all coming from angle A. Which side is opposite angle A? That would be the side where the 12 is. And which side's adjacent? Well, there's only one left. And if you think about it, isn't side AB next to, okay, adjacent to A? So once you have everything labeled, that really takes the hard part out of it. Now all I need to do is just write down the numbers that correspond. So what is the sine of A? Sine is the opposite over the hypotenuse. So that would be 12 over 13. What is the cosine of A? That would be the adjacent over the hypotenuse. That would be 5 over 13. And what is the tan of A? That would be the opposite over the adjacent. That would be 12 over 5. Now, where things get a little interesting is if you look now at the next three parts. Now it's saying, let's find the sine, cosine, and tangent again, but this time let's do it not from angle A, but from angle C. So what's going to happen is that the hypotenuse is the hypotenuse, but which side is opposite angle C? Well, isn't opposite angle C pointing over here? And is it adjacent to C pointing over here? So what ends up happening is that the opposite and the adjacent end up flip-flopping. So opposite C is going to be the 5, and next to, adjacent to the C, is going to be the 12. But I hope you see what I mean. The hypotenuse is always the hypotenuse. That can't change. So what's the sine of C? Well, the sine then is the opposite over the hypotenuse. So look at the labeling. Opposite of C is 5. The hypotenuse is 12. What's the cosine of C? Well, that's adjacent over the hypotenuse. So that'd be 12 over 13. Excuse me, this is 13 as well. And then tangent of C. Remember, tangent is the opposite over the adjacent. So that would be 5 over 12. So in any one diagram, you will see a lot of repetition. That's okay. Notice that there's some of the answers are the same. Like, for example, the cosine of A is the same as the sine of B. That's interesting. And the sine of A is the same as the cosine of C. We'll talk more about the relationships later of that. But let's talk about now finding missing values. All right. So example 2 says find x to the nearest tenth. So first thing I want to point out here is that what I see is I see a right triangle. Find a missing side of a right triangle. What I would say to you if we were in class is that students oftentimes want to use the Pythagorean theorem here. Because don't you use the Pythagorean theorem when you want to find a missing side in a right triangle? And the answer is yes. But you do the Pythagorean theorem when you know that you have two sides. I don't know that I have two sides here. I've given one side, the 12, right? And I'm trying to find the other side, x. What they give us is they give us an angle. So usually trigonometry is a mix between angles and sides. In right triangle trig, everything is going to be based off right triangles. All right, so here's what we're going to do. From the perspective of the given angle, which is the 37, I want you to label what is opposite, what is adjacent, what is hypotenuse. I always say do hypotenuse first. Hypotenuse is across from the 90-degree angle. Okay, so that has to be the 12. And then the question you have to ask yourself is, what's the relationship between the position of x and the angle 37? Well, isn't the side x opposite the 37? So what ends up happening is that the adjacent side isn't really necessary here. So what I would say to you is go back and look at SOHCAHTOA. In which of the three trig functions, sine, cosine, or tangent, deals with the opposite and the hypotenuse? Well, the O and the H is only attached to the SO, isn't it? So remember how that works. So, right, it was the sine of the angle 37 is equal to the opposite over the hypotenuse. So, in a case like this, what you have to do to solve is I have to put sine 37 over 1. I'll cross multiply. Now, when you